Yeah, assalamu alaikum everyone. Can you hear me?
Yes, we can.
Okay, so hope all are well. So basically today is our third number class, and I hope all of you already get the previous material, mainly slide or recorded video class or practice code, and also make practice. So after completing the 3 hours live training, then we talk about the problem solving class. Okay, for previous classes. If you have any problem or any confusion or any doubt, then we'll discuss about that. Okay. Okay, so let me share my screen. Yes. So basically today's session I discuss about that how to calculating any indices from satellite images. Okay. So using Landsat or Sentinel, how we can easily compute the different types of indices and filtering the and displaying the Sentinel to satellite imagery and monitor the different types of indices and also extract the water body and also discuss about the time series chart. So previous session we discussed about this topic is not completed for the time series chart. Okay, so let's discuss about that also, and also annual composite how we can easily create. We also discuss about that in this session also, and how to export any shape file and how to add the gradient lesion or flood mapping. Okay, and also monthly time series chart we also discuss about that. So let's go one by one. I try to complete all of topics. So first of all, I discuss about the time series chart, how we can easily create in remote sensing. I will try to show you that all of those step by step. Then I hope we can easily use this type of technique to use the time series chart using Google Earth Engine. Okay. So in the remote sensing, we are use the different types of time series chart for the different purpose. Okay. Okay. Sometime for the crop health monitoring or growth monitoring. So different types of way. Suppose I will write some example, then get the idea. So we are using the time series chart. Suppose vegetation time series analysis. Time series analysis. Okay, so this is the one kind of example for time series analysis, vegetation time series analysis. And using the how I can use the vegetation time series analysis. Suppose we can use NDVI. We already know about that NDVI, normalized difference vegetation index, or EVI, enhanced vegetation index. We can easily check the trend trend of vegetation. So basically using that we can easily monitor the vegetation health. Okay, suppose for monitoring of vegetation health over time. Okay, suppose for a specific time we can easily check about the vegetation health using the time series analysis. Not only for that, we can also check about the using the time series analysis. It's called the phenology. Okay, phenology analysis. Using the time series chart, we can easily identify the phenology analysis. Phenology basically it show about that start basically SOS, season of start, then POS, and EOS, end of season. Okay, peak of season, then end of season. We can easily identify. Suppose for any specific crop land or a specific agricultural land, we can easily identify using the phenological analysis, using the help of time series. We can make the phenology and identify season of start, peak of season, end of season. We can easily identify. So this is another example. Third example, we can say that suppose drought indices. Drought indices. So using the drought indices, different types of drought indices, suppose VCI, it's one kind of indices, vegetation condition index, or TCI, temperature condition index, or VHI. So this type of indices, we can make the time series, okay, time series, and analyze the drought condition for a specific period. Okay, we can easily do it. As well as we can also use the time series for vegetation. It's called the deforestation monitoring. Deforestation. Deforestation monitoring. monitoring. Okay, deforestation monitoring, forest cover change. Okay, you can easily identify forest cover change trend. So here I use some example, you can see. So all of example is not possible to show in this one session. So I will try to show you that step by step. Okay, as a, wait, we can also use, no problem. Yeah, so we can also use the SPI, no problem. Okay, so SPI or SPEI. So this type of index we can use, no problem, for the drought monitoring. But you can see using the time series we can do this type of analysis. Okay, so I'll show you the example for the vegetation time series analysis. So using the vegetation time series we can easily identify for monitoring the vegetation health over the time, then phenology model, then drought indices, then deforestation monitoring, mainly forest cover change trend. We can easily identify using this type of time series analysis. So we are not only use the vegetation, as well as we can also use the other time series. Suppose second example we also show you that it's called the climate and drought time series. We can also set another example. Suppose climate and drought time series. So in the climate and drought time series, what we can do? Suppose one example, you can say that rainfall time series. We can easily create the rainfall time series. Okay, rainfall time series. We use the different types of data. Suppose charts, satellite data, or we can also use the GPM, mainly global precipitation measurement data for rainfall analysis. We can use. So for rainfall analysis, okay, but process is the same. Suppose if you make the time series analysis, suppose for NDVI, same process you can also apply for the rainfall. Okay, but I will show you the example. So after completing this class, you also try. Okay, you also try to identify phenological model or drought indices model, or also forest cover change or rainfall time series. You also try. Okay, but in this class, I will show you the practical example, one or two example. But same process you also try to apply. Okay, this type of step you also try to apply. Not only for that, we can also make the time series analysis for it's called the temperature. Suppose temperature time series. Okay, in the temperature time series we can also use to identify. Suppose we can easily use the Moody's LST data. Okay, as well as we can also use that ERA5 temperature data. Okay, to identify for the temporal analysis of temperature, we can easily identify. As well as we can also use that number 3, we can also that SPI, mainly it's called that standard precipitation, okay, precipitation index. So it's one kind of index to identify for drought. We can easily identify using the SPI. And we can also use the another, suppose evapotranspiration trend. It's called the ET mainly evapotranspiration trend. Okay, so we can easily use the time series and we can easily do this type of analysis. Suppose rainfall time series, temperature time series, SPI time series, and evapotranspiration time series. Okay, and we can also say that another one. Suppose we can also use another example for water resource time series. Suppose water resource time series for the water sector or water resource time series. Suppose one example we can say it's a surface water extent. Okay, surface water extent, SWE, surface water extent. We can easily identify for the different time surface water extent, how much area increasing or decreasing, the extent the area, we can do it. As well as we can also do suppose it's called the suppose lake or reservoir storage trend. We can also use the time series to identify lake or river or reservoir, any water reservoir storage trend. We can easily identify. Okay, and another thing is that it also possible we can use the groundwater storage for the different time. Okay, groundwater storage for the different time. So for the we try to apply the GRAC. This GRAC data we also use to identify for the groundwater storage for the different time. So this type of example we also apply for time series analysis for the water resource sector. Not only for that, we can also add a lot of things. So I will show the some main theme about that. Okay. As well as land use, land cover, we can also make the analysis. Suppose temporal analysis. Okay. And we can also calculate the NDSI. Yeah, a lot of things we can easily compute. No problem. Yeah. Suppose LULC or LULC change. In this time, we just simply display the result for suppose annual classification to make the land use land cover change analysis for the different time. Suppose 1990, then suppose 2000, then 2010. Okay, suppose 2020. We can easily make the change analysis for the time series. We can also do it in the land use land cover. We can also connect with urban expansion. Okay, suppose urban expansion for the different time period, or urban expansion detection for the different year. Suppose 1990, then 2000, or 2010, or 2020. So different time we can easily make the analysis for the urban expansion detection. Okay, and also identify another thing. It's called that agricultural area trend. Okay, suppose agricultural area trends we can also identify, okay, by the time series. Okay, using suppose NDVI, agricultural area trends, using NDVI we can also identify. So lot of example is available. Suppose another sector, suppose air quality, we can also apply the time series. Air quality and pollution trend. So in this trend, suppose one example, you can say that it's a suppose AOD, aerosol optical depth. We can identify for the time series analysis of the AOD, aerosol optical depth. Suppose NO2, nitrogen dioxide, or sulfur dioxide, or any other gases we can easily identify. Okay. Then suppose we can also use it for suppose urban air quality analysis. Urban air quality analysis for the different time period. Okay, we can easily identify urban air quality analysis in this section. Okay, so there's a lot of example for every sector. We can set the example. Suppose suppose I show the agriculture and crop monitoring. So we set the example, suppose to identify yield estimation, okay, as well as already discuss about the crop phenology. Okay, crop phenology we set, and then suppose water stress we can also identify. It's called the crop water stress index. Okay, CWSI, crop water stress index for the different time we can easily identify. Okay, as well as also can also apply for the disaster and flood monitoring. Okay, there's a lot of things we can easily use the time series for the different purpose in remote sensing. Suppose disaster and flood monitoring. So in this case we set the example, suppose flood inundation mapping. Okay, or cyclone rainfall analysis. Okay, cyclone rainfall analysis. Okay, or drought index we already know say about. So this type of example we also set in here. Okay, as well as also LST we also use, suppose in the urban heat island we can also identify, and LST. Okay, suppose in this case we can easily make the LST trend, make the time series chart and identify LST trend, and also make the urban heat island trend. A lot of example you can set, as well as the fire monitoring, soil moisture. So there are a lot of things we can use the time series chart, different types of analysis. Okay, but for that, first of all we need the data set. Mainly we need the image collection. So when you make the time series analysis, we need the image collection. Without image collection we cannot make the time series chart, and this image collection can be two types in in Google Earth Engine. Okay, suppose first one, it's called that ready-made image collection. Ready-made image collection. Second is the unready-made image collection. Unready-made image collection. Okay, so this image collection can be two types. First type is the ready-made image collection. Second is the unready-made image collection. Suppose what is the ready-made image collection? Ready-made image collection, we find out the ready-made product. Okay, it show the ready-made product. It show the ready-made product. So what is the ready-made product? Ready-made product, if you check, we already use some data. Suppose I simply search here Moody's NDVI. So if you check, we find out this type of data, and if I just open the data, suppose this data is simply open, and it show the ready-made product. If you check in the bands, we find out the ready-made band NDVI, ready-made band EVI is called the ready-made product. Okay, suppose I also search Moody's LST, so then we can easily find out the Moody's LST that it's one kind of ready-made data, because all of analysis is already done for this type of data and create the ready-made product. If you check, we can easily identify LST 1 kilometer. So this is the band, it's a ready-made band. So from this band I can easily get the information of LST or land surface temperature easily. So it's called the ready-made product. Okay, and what is the unready-made? Unready-made, it's just we find only we find out the reflectance value. Okay, we find out only for the reflectance value, mainly band value, band pixel value we find out. Suppose Landsat, Sentinel, if you check, suppose simply search here Landsat. So we find out only for the Landsat product or Landsat band. Okay, suppose I can see this type of image collection, we find out only for the reflectance value, B1, B2, B3, this type of band we find out. But we are also using this type of image collection and make the band. Suppose using this image, I can easily compute the NDVI or NDWI or any other indices I can easily compute. Okay, and then we also make the time series chart. So these two process I will show you that for the ready-made and unready-made, how we can easily handle and make the time series chart. Okay, so let's go. I will show you that one example for ready-made product. Just I click on browse data catalog, and in the Moody's section, if you check, you can see it's the product. So product mainly it's ready-made, not need to put any kinds of algorithm or any kinds of method. It's just ready-made data. So here we find out all of ready-made data. Okay, all of are the ready-made product. Okay, for different types of Moody's ready-made product we can easily find out in here. Suppose I will show the one example. Suppose it's one kind of data. You can see this is the data, and it's a aqua. So try to face, suppose Trera. I will try to find out the Trera land surface temperature. You can see different types of product. You can see this is the leaf area index, gross primary productivity. This is the NDVI. Okay, also you can see the different types of product. You can see this is the aqua land surface temperature. equal and separate temperature. You can say terra land surface temperature. Okay, terra land surface temperature. And all are the same process. All of data set are the same process to make the time series chart. Terra land surface temperature. Okay, so suppose I want to use this data. Terra land surface temperature, emissivity 8-day global, 1000 meter, okay, or 1 kilometer resolution, this data set, and it's one kind of ready-made product. If you click on here, then you can get all of the information about this product. So this data set, if you check, we find out the data set from 2018 February to 13 August. This is the last time period. Okay, and it's one kind of ready-made data set. So this data set, we find out this band LSTD 1 kilometer. Okay, it show the day land surface temperature. Suppose I want to use this image collection and make the time series chart. Okay, so first of all, just simply copy this and paste here. Okay, then give a name. You can put any name. Suppose I put the name is dataset. Okay, then equal. So now this image collection I simply import in this variable. So now simply filter this image collection. Okay, we already know about that different types of process for filtering. Okay, suppose first just simply put the filter bounds function. Filter bounds with your intersecting with your study area. So for that you can simply import your shape file. Okay, so suppose I just simply import one boundary from my asset tab. So this is my shape file. Suppose I want to work for, suppose I import the Bangladesh all of district. I simply import in my boundary and I put the name, it's a ROI. Okay, so now just simply filter bounds with my study area ROI, and it's a ready-made product. Okay, ready-made product we don't need for filtering the image metadata or image properties, suppose cloud cover or less than 1%. So this type of things don't need for the ready-made product. For the ready-made product we simply select the band name. So in this case, if you check this image collection have band, so I just use it LSTD 1 kilometer, and this unit is the Kelvin. Okay, so we also change the unit degree Celsius. So just paste here. Okay, and put the time period. Suppose put here the filter date and put the start and end date. Suppose I put the time year of 2025, 1st January from 2025 August 13. So I take this type time series data. So now let's check how many images is available for this time. Just use the print function and call this data set and use the size function. So now let's check how many images are available. We find out the 28 images are available. So this is my image collection. Okay, so I use this image collection and make the time series chart for my study area in Bangladesh between this time period. So for the time series chart, when you make the time series chart from the image collection, we need to use a function. I simply search here chart. And if you check, we find out this is the function. Okay, you can see this is the function UI chart image.series. First argument is image collection. Okay, so without image collection we cannot make the use the function. Okay, when you use this function you must need the image collection. Okay, so and you can see the second argument is the region mainly your shape file. Okay, where you need the time series chart. Then reducer is an statistical function. Suppose you need the average time series chart or maximum time series chart or minimum time series chart or standard deviation time series chart. Scale is mainly resolution of your satellite imagery. And X property, we are use the default system time start. So now we are just use this function, just a copy. And then paste here. Okay, so first of all, just I make a dictionary, or if you want you can just put only for the value also, there is no problem. Suppose I make a dictionary, so curly bracket start and curly bracket end. So now put the keyword and key value. So this is my first keyword, image collection. So for that I put the key value this data set, because this variable stored the total number of image collection in this variable. Then region, it's your shapefile variable name. Okay, this shapefile. So shapefile variable name is RY. Just I put here ROI. Then reducer. So in this case, suppose I make the average time series chart of LST. So for that, put here EE dot reducer dot mean. Okay, it's compute the average time series chart. Suppose I need the maximum time series chart of LST. So put here the max. Suppose I need the minimum, put here the mean. Okay, suppose I calculate the average, so mean. Then scale. Scale is the resolution of your satellite imagery. So in this case, for my, what is the resolution? 1000 meters pixel size. So this is the resolution. Just I paste here. Then X property. X property default. We are use all time system time start. Okay. So now this is the function help you to make the time series analysis. Now this thing simply store it in a variable. So I put the variable name, suppose chart equal. Now print the chart and run the code. So now it's working. Yeah, so we find out this type of time series chart, but this time series chart have a problem. So what's the problem? If you check, it show this type of value, you can see 15,215. Okay, we find out this type of problem. So these things we need to, if you check the image data set information, they're also mention a scale. Okay, so before making any analysis, first of all you try to check in your data set have any scale or not. Okay, if this scale is available, then you try to use this scale and make the reprojected the scale value. Otherwise it showed this type of large value, you can see 15,000. So now I want to use this scale and reprojected my scale value. Okay, then it show the better pixel. Okay, so this is the scale value 0.002. Okay, this value I need to multiply all of images, 28 images I need to multiply. Okay, so now how I can multiply these things? Just we create a function. Suppose we just make a function. This function automatically compute all of images with 0.02. This value automatically compute using this function. So let's go create a function. So for the function, first of all, just define the function variable name. I put the name, suppose rescale LST equal function keyword. And now take the element name. I put the element name, suppose img, and now use this curly bracket. In this curly bracket, I just put my argument. So what is my argument? My argument is that this element, I want to multiply with my scale factor. So just put here return this element, multiply this value 0.02. Okay, and now after multiply 0.02, this property will be copy and apply all of images. So for that, just use here the copy properties. Just I copy this property after multiply from this element and apply all of images. Basically between this time period, start and end time period. So just simply put here the system time start to system time end. So now it create a function. So it create a tool or helper. So this tool or helper, when you input the collection, suppose this is my data set, we have total 28 images. So when I connect with my function, then each image come in this tool and multiply with this variable 0.002. So now how I can connect? For connecting, just call this collection, image collection, 28 image collection. I just copy and connect with my function. And for connecting, just use here the map function for connecting this function with your collection. So this is my collection and this is my function which I created. So just I connecting using this map function. So now this variable is stored all of images with multiply this value 0.02. So now this is my final image collection. Just I copy and just I use it in here and run the code. Okay, so we find out, if you check, so now we find out this type of value, but now you can see it show the 304 because it's a Kelvin unit. Okay, so this Kelvin unit I want to convert into degree Celsius. Okay, so for that I have to know about the Kelvin to degree Celsius. What's the formula or what's the equation for conversion Kelvin to Celsius? Simply search, suppose Kelvin to Celsius formula. So I have a Kelvin scale. So this scale I want to convert into degree Celsius. So for that you can see, just we simply subtract this value 273.15. I have a Kelvin data. I have a Kelvin result. So when I subtract this value, then I got the result in degree Celsius. Okay. So let's go just simply subtract this value and convert into degree Celsius. Just I copy this value. And I want to just simply put here subtract 273.15. Okay, this value I simply subtract, and now it's converting into degree Celsius. So now run the code. Okay, so now if you check the value, you find out 31.15 degrees Celsius in the May 9. Also you can see June, you can see the January 22.3. Okay, you can see the January 9. And if you check what's the you can see the 8 days interval. Okay, 8 days interval, 8 days interval. Every time we find out the 8 days interval, because this data is the 8 day, you can see the temporal resolution is the 8 day. So that's why you find out that 8 days interval. We find out the first value in 1st January, second value we find out that after 8 days in the January 9, then 17 January. So every 8 days it show you the data we find out in here. Okay, it also global. If you check, suppose you need the daily data, so then you try to use here the daily. It also have the another, you can see the daily. Okay, daily global, we find out the daily, suppose every single day we find out the data, and it's the 8 day. But this type of data or this type of temporal resolution, further we also compute, suppose monthly average or annual average. So in this session I also show you that, inshallah you can easily get the idea how to convert monthly or annually, this type of daily or 8 days data. You can get the idea. Okay, so we find out this type of time series chart. Okay, and this chart you can also represent more better way. Suppose you can add the title, also add the X level, Y level title, then it look more better. So for that you can simply add some title. Suppose for that just use here the set options. Just add the chart title. Suppose I put the title is that LST time series chart 2025. You can put anything, add any title. So then Y level basically vertical we represent V axis. Put the title for the vertical, so I put suppose LST degree Celsius. Okay, so you can also put the symbol of degree Celsius, so it look more pretty. So for that I simply search here. Okay, you can see degrees, just a copy degree Celsius symbol and paste here. Okay, but it not work, just a minute. I simply search here degree Celsius symbol. So this is the symbol, just I copy and use in my chart. Okay, it's perfect. Yeah, and then we also put here horizontal, basically x level. So X axis title. So this title, it's a time or day. You can put anything. I put the time. So now run the code. So this type of things also added in our chart. Okay, you can see, we find out this type of chart. This is the LST time series chart 2025 LST degree Celsius, and it's a time. And also you can download the CSV file also. You can also download the photo as a PNG file format for the chart. Okay, so this is the way to make the time series chart for ready-made product. So now you can also try all of data. You can see there's a lot of data for different product. Suppose you can see vegetation, okay, for NDVI or EVI. Also you can see the leaf area index, okay, leaf area index, okay. Also you can see the net evapotranspiration, okay. Also you can see the net evapotranspiration gap fill data, gross primary production data, okay. Different types of data we can find out for the ready-made. So for the ready-made data set, just apply the same procedure, and make the time series chart. Same method to make the time series chart for any ready-made data set, okay, when you work. Or you can see that snow cover data, okay, daily snow cover data. So you also try to use this type of data and make the time series chart, but procedure is the same, okay, any data set for make the same process to make the time series chart. Okay, anyone any question, you can ask me about the time series chart,
Sir, I have a doubt.
please.
Sir, when we create a function, in the element we write img.
Yes.
So can you explain more about
Okay, so it's
why does
okay,
it,
so it's
what
what,
does it mean?
okay, so it's one kind of variable. You can put anything. Suppose I put the element name is the A or A. So A basically it's one element. Suppose I take only for the one element. So this element I just return. So just put here the A again. So just I use A and further keep the same. So now it also work. There is no problem. Okay.
Sir,
Oh, we also need to put the A in here. So just I put here the A. Okay, so in this case we create a function. Okay, our main target is that we create a function. So in this function, for the what the structure of the function, we already know about that. For the function we need the variable name, then put the function keyword, then put the element name. So element is different on your work. Okay, suppose in this time I need to multiply this value and subtract this value. So I take a one element. Suppose I take the element name is A. You can put anything, any variable as a element.
sir, suppose
Yeah.
suppose we have 28 element 28 image here.
Yeah. Yes. Yes.
So how element A connect with all the 28 images?
Yes. Using this data set. Okay. Because this 28 images stored in this variable, data set variable. So when I create this function and connecting with my data set, so this 28 images connecting with this function. Suppose from this data set one by one, suppose first image, second image, third image, just input in this function, just input and compute this process. Suppose multiply and subtraction, just compute this process and make the analysis. Okay, so we create a tool. Suppose it's one kind of tool. So this tool basically help you reuse your code. Okay, this tool or this function help you to reuse your code. So in this case, I have total 28 images, and all of images I need to multiply with the same value, okay, with the same value 0.02, and subtraction with the 273.15. So I need to multiply and subtract the same value for every image, okay. So that's the reason I create a function to reuse my code, okay, and it's multiply and also subtract for each images. And copy properties, you can see, first of all I simply take the one element, so it's only for the one element, okay, one element I take and multiply 0.02 and subtract with this subtract this value. But I have total 28 images, so this all of images indicating, so for that I simply call the copy properties up from my element, okay. Multiply after multiply this copy, I simply copy these properties and apply all of images, system name start to system name end. Basically this system name start and system name end indicating about the total images between this time, total images 28 images, okay. So in this time copy properties, it's just copy the properties after multiply, okay, and connect with our element and apply all of images between this time period, and in my system, suppose this full code we can say as a system. So in this system I already define a time period, this time period start and end. So this thing simply mentioned in here, start time start and start time end, and between this time period are available total 28 images, okay. So that's the reason. So a lot of time also use this type of function. Yeah, please. Yeah, any question, please? Okay, I hope you also got the idea about that. Okay, thank you. Okay. So now we find out this type of time series chart for using this data. So you also try to other data set for ready-made product. Mode is evapotranspiration, mode is gross primary production. Okay, and Google Earth Engine has a limitation. I also write about that. Sometimes we chart is not work. Chart is not work. Okay, we face some problem. Okay, sometimes. So basically, suppose it show that there's a lot of data. So for that, we need to download the data CSV file. CSV we just apply and download the data. So inshallah further class we will discuss about that how we can easily download the data in a CSV file format. This time series data we download the CSV file without creating the chart, because sometimes chart is not work. When you work with lot of data set, then it show that chart is not work. So that's why we need to apply the another method to download the data directly in CSV file or Excel file. Okay, we download it. But you can also try, but I will show you this process inshallah for the class. Then you can easily get the idea how we can easily work with CSV. Okay, yeah. So now I want to work with suppose annual. So we find out this type of temporal, you can say 8 days, but I need the data for annually and also need the data for monthly. Suppose I simply define my year from year of 2010 to 2000, suppose 24 December 31. Okay, so it also work. We find out that 8 days temporal chart. Now we can set the total 690 images, but this image collection 690 image collection I need to convert into monthly and also yearly. Suppose 2010 to 2024 is year, all of month I need to make the time series chart. So let's go ahead to discuss about that how we can easily work with monthly and annual time series chart. But this same process you can also apply for any other image collection. Same process. Suppose monthly and annual time series chart. Okay, and this thing is similar with the ready-made and ready-made, both are the similar, but main focus is our image collection. Suppose I have total 690 images between this time period, So now this image collection I need to compute monthly and annually. Okay, so for that, this just take a variable. Suppose I put that start year. I put the start year in year of 2000, suppose 2010. Take another variable, suppose in year 2024. Okay, this is my start in year, simply define. Okay. So after defining the year, then need to define the date. So put the start date. I put use a function ee.date from ymd. Okay, so it's one kind of function. If I show you that, suppose ee dot from, okay, this is the function. So you can see we have simply defined the year, month, and day, and also time zone. Time zone is not need. We define the year, month, and day. This is the start date, and it return a date given year, month, and day. Suppose you can check. I put the year 2013, month suppose January, February, March. I put the March, and day suppose 15. So we can simply put this type of value. So just we try to put the time. So start date. So it will be start from the start year. Suppose 2010. I put suppose first month, mainly January, and put the first date, and take the another variable, suppose in date, and I put here ee dot date dot from ymd, and define in year, it's suppose I just simply take the year 2025 also. So for that, simply define plus 1. Okay, and define suppose 1st January 1st. Okay, so I define it this type of time. So basically this plus 1, it's indicating about the full coverage until the end of the last year. Okay, so that's why we simply put in here. So now we make the sequence, year sequence and month sequence. So take a variable, suppose years, and make the sequence. For the sequence, use the function ee dot list dot sequence. Okay, and start, this is the start year, and this is the end year. Okay, so now it just show the year 2010, 11, 12, 13, 14 up to 2024. So now take the another variable, suppose months, and make the list ee dot list dot sequence, and put that January to December. Okay, sometime you need the result. So then put the seasonal time. So in this case, you can see we face this type of problem. Okay, you can see this is the problem. We find out the error generating chart user memory limit exists. So it means that there are a lot of data between this time period. Okay, where you can see when I just put this data and make the chart, we face this type of problem. So it means that there's a lot of data. So this is the one kind of limitation to creating of the chart in Google Earth Engine. So for that, we need to apply the CSV file when you work with lot of data set. Okay, lot of data set between this time period. Okay, so in this I'll try to discuss in the next class inshallah about that how we can download the data in CSV. I think it's added in the 5th number days. Yeah, 5th number days we'll also discuss about that how we can easily download the data CSV format. Okay, so then you can easily use it for download the data, any data, download the data in CSV file, no problem. Okay, so now I simply define the years and month list or sequence. But when you work with the seasonal, suppose you need the data for the summer season or rainy season, then she will put the seasonal time period. Okay, suppose January to June or July to October. So this type of thing we can simply mention, but in this case I take the data full year. Okay, so now we just need to create the annual image collection. Okay, so using total 690 images, we need to create the annual image collection. Suppose 2010, 2011, 2012, 2013, 2014, 2015. For each year, all of image, I just make the average. Suppose in 2010, all of image, create the mean. 2011, all of image, create the mean. Okay, up to 2024, all of images, yearly images, create the mean. Okay, just we apply this. So now we create a loop. Okay, we create a function, and this function helped me to compute each year all of images average LST. Okay, and I have this image collection. Okay, but now I want to compute yearly, each year, 2010, 2011, 2012, 2013, 14, up to 2024. So how I can create? So I have image collection. When you compute the another image collection, then we need to apply this function. This function called, okay, I'll show you the function. Image collection from images. From image, where is the image collection? Yeah, so this is the function e.image collection from images. Suppose I have total 690 images, but now this 690 images I want to convert annual image collection. I want to convert into annual image collection. So for that I need to use this function. Okay, and this function return the image collection containing the given images. Okay, and one argument images, and it returned the image collection. So now I have total 690 images. This 690 images I convert into annual image collection. So how much year? 2010, then 11, then 12, 13, 14. So all of images, all of yearly images I need to convert. So if you just simply print, suppose show you that, just simply print the years and run. So now I can see it just make the list total 15 years. Okay, 2010, 2011. So now for each year I just make the collection, yearly image collection, and I compute the mean for each year. So let's go, we try to compute. Take a variable. Suppose I put the variable name is annual data set. Okay, and now I apply a function. dot image collection dot from images. Okay, this is the function I just put. So now I can directly put the image, suppose 609 image I can directly put in here, but now I want to convert yearly. Okay, this image collection I need to filter yearly and take the mean. Okay, so for that what can we do? Suppose I create a loop or create a function. So this function every year, suppose 2010, all of images come in this function and compute the mean. Again 2011, all of images come in my loop and compute the mean, and up to 2024 all of images come and compute the mean of LST in year of 2024. So for that we create a function. Okay, we create a function. Suppose I create a function keyword I just put and make the element. So I take the element, suppose year. Okay, so year is my element because each year, suppose 2010, 2011, 2020, all of year come one by one in my loop and then compute the average LST. Okay, so I create the function and put the element is the year. Okay, so now what is my argument? So for the argument, just put the curly bracket. In this curly bracket, I just put my argument. So what is my argument? My argument is that I want to filter this data yearly. This data I want to filter yearly. So this 690 images I just filter yearly. So take a variable. Suppose I put the variable name is dataset, and this 690 images is stored in a variable. Okay, so what is the variable name? We find out. This variable, because you can see this is the two image collection, dataset and rescale dataset. Okay, so in the rescale dataset, basically we find out the reproject our scale value and also find out the degree Celsius. So just I use this dataset. Okay, just I copy, and if you print, suppose you check how many images for that, just we find out the same image. Suppose just I copy rescale LST and check how many images. So we find out the same number of images. Oh, just a minute. We find out the same number of images. Okay, we can find out the same number of images, but in this case this 690 image is reproject our scale value and also degree Celsius unit. So I want to use this 690 images which is stored in this variable rescaled LST. Just I copy and paste here. Okay, so now I just call my image collection. This image collection I want to filter yearly. Okay, so how I can filter yearly? So for that, just use here the filter function and define ee dot filter dot calendar range. So now this is another new function, calendar range. So if you check what is the function about the calendar range function, just I open it in the top tab. So calendar range, you can see we put the start and end and also put the field. Suppose I put the year, start year and end year, and fill the unit, basically year. So if you check what is the start basically the calendar field. Okay, and you can see in that we find out that desired calendar field, and also field, it can be day of the year, you can see month or year, then hour or month. So in this case I want to apply yearly for each year. So I put here start, I put the element year and also put the year, and unit is also year. Okay, so I define calendar range yearly and also unit is the year. So now all of yearly image we just compute mean. Okay, so after creating this mean in this function, what I return? So I want to return this data set, set with yearly. So just put here the year. Okay, and also put the set system time start and define the ee.date from ymd. I put here suppose year and show the first January month and first date. Okay, 1st January, 1st date. So in this data set, this is the function. Okay, So this function I need to connect with my year list. We already make a list. If you check, this is the year list. So just I copy the years list and connect with my function. Just paste here and connecting, use the map function. Bracket. Okay, so close the bracket. So now it's create a function or create a loop. So in this loop, what happened? So I have MS collection, total 690 MS collection. So this MS collection I filter yearly, okay, and compute the mean, and I return the dataset yearly. So now this from this list, so this variable is stored the collection of year. So now each year, suppose 2010, 2013, 2014 up to 2024, each year come in this loop and compute the average, okay, and return the yearly data set. So now if you print, suppose just print the annual data set and run the code. So we find out the total 15 elements, mainly 15 years data. So if you check, this is the first, this is the 2010, okay, this is the another 2011, this is the another 2012, so up to 2024. Okay, so this is my annual image collection. So now I want to make the time series chart. Okay, so now I apply the same procedure, so which I already show you that how we can make the time series chart. Suppose I want to apply this code. Just I copy the same line of code and then paste here. So now simply change the annual data set. Just I change my image collection. Okay, now let's check what happened. Okay, so if there's a problem, no feature contain the non-null values of system time start. So now we try to use the function, suppose this function. So you can see this is another function, UI chart image dot series by region, and it also you also need the image collection, you need the regions, also need the reducer, then need the band name, scale, x property, and also need the series property. Okay, so now the series property we need because we just make the time series chart for suppose 2010 for one column, for 2011 for the another column, 2013 for the another column. So I think further we need to use this function to create this type of chart. Okay, we need to define the x-axis, also define the y-axis, and series region labeled by the series property. Okay, so let's go try to use it and then check what happened. because in this case we try to check the chart for each year. Okay, so let's go try to check it. Just test and make a dictionary. So curly bracket start and curly bracket end. First of all, collection. So I already make the annual collection, this annual data set. And paste here. Then regions, we simply define our study area, which is ROI. Reducer, I compute EE dot reducer dot mean. Band, it's our band name. Okay, so this is the band name. LST 1 kilometer. This is the band. Scale is the resolution of your satellite imagery. X property. So X property define here system time start, and series property we put the suppose site, or I put anything, suppose just I put the site and check what happened. Just let me print. Oh sorry, it's a just put the quotation. Let me, okay, just a minute. Let me add suppose set chart type, and I define it's a column chart. SYS. So now let's check. And it takes a lot of time because I just use for the whole country boundary of Bangladesh. Okay, but when you work with a small state area, then it not take much more time. Okay, it very quickly can get. But now this tracer is for whole country boundary of Bangladesh average LST. Okay, so it can just now it's work. So we find out this is the average LST, land surface temperature for January 2010, 2011, 2012, 2013, 14. Okay, so it is a whole year. Okay, whole year average LST for each year we find out. Okay, so now okay, you want to add the suppose different types of things. Suppose I add some option. So for that, use here dot set options and also put the title, suppose annual time series chart 2010 to 2024. Then suppose put here the vertical axis, so p axis, put the title LST. Your LST degree Celsius you can put, or horizontal axis, put the title, it's here. Or here. Okay, so next we find out this type of chart. For bar column chart we can also find out, we can easily identify which here is more LST, we find out. Okay, okay, but first time why this function is not work, so let me check. Suppose I want to use this function, series function. Now let's try to make the time series chart again. So now I simply change this image collection, annual data set. Okay, so now let's check. Okay, so it's okay. Okay, so now if you check, we find out the chart, it also worked. Okay, and it also worked. Okay, but what's the basic difference between these two function? Okay, when I need to use this function and when I need to use this function. Okay, so you can also get, suppose it show the line chart, suppose you want to display, suppose column chart, so simply use this function. You just copy and also just simply connect. So now you find out the column chart also for this chart. So now let's check, you can check, it also works. But different function we have for the different purpose. So you can see it also work, there is no problem, we find out the result. Okay, but now we are just use UI chart image dot series and make the column chart. Okay, and it also worked. So using this function UI chart image by region, but there are the two common difference. This difference is that when you compare, okay, suppose you want to compare the time series chart for the different regions, then we try to apply this function. Suppose I want to compare the LST Dhaka and Gazipur to different city, okay, and make the time series chart for the different cities. I need to make the time series chart, then we need to use this function. Okay, and if you check the argument, it show the regions. Okay, regions, but you can see it's only for the region. But when you compare, suppose I have a one district Dhaka, another district for Gazipur, so now different two district I want to compare and check what the LST time series chart. Suppose I have a two cropland, suppose rice and sugarcane, I want to compare the NDVI phenology. So that then I need to compare the time series chart for crop, sugar cane and rice at the same time. Then I can easily get the idea. Okay, we can easily get the idea from here. Suppose let's go through the one example, practical example. So in this case, I just take the data for Bangladesh boundary. Just a minute. Okay, display the map first, then I show you that. So we find out this this my okay. Let me show the map first. So we're going to display the map. Display the map. So how I can display the map? So previous class I discussed about that for NDVI mapping. So same process, just apply. So take a variable. I put the variable and suppose mean LST. Put the mean LST.